Hey, everybody. How's it going? Last one. I guess I'm the only thing standing between you and partying, so I'll try and make it fun. So yeah, we're going to be talking about Firebase and one of the buzziest buzzwords since Web 2.0, the Internet of Things. Hopefully it'll be fun. So there's my self-introduction slide, but that's already done, so I will skip it. But I love hearing from people, so if you're ever building anything cool and you want to share it with me, or you have feedback about like a Google API or something, you can always feel free to reach out to me. Or please do reach out to me. There's my Twitter handle, and I have a web page with like a home page with links to other methods of contact. So, since you know a little bit about me, I'm going to ask all of you some questions. How many of you are electrical engineers by trade? One? A few people. OK, so I'm going to apologize now for all the oversimplifications and sins against electrical engineering I'm about to commit. So we can talk about it after the talk. How many of you know JavaScript better than C? That's what I thought. Me too. How many of you have an Arduino or Raspberry Pi that's at home sitting on a shelf, all lonely, not doing anything? Yeah, I have that problem a lot too. Oh, actually, that was all the questions. But yes, this talk is about solving that problem for that dusty Arduino. We're going to make it happy. And here's our plan. We're going to do a crash course of about 5 minutes of electrical engineering, targeted at people with like web dev-ish backgrounds. Then I'm going to share one of my favorite recipes for IoT hacking. Then I'm going to prove to you that it is fun and easy. I'm going to build something pretty much from scratch and write all the code from scratch. And then we're going to do some silly demos. Sound like a plan? Let's do it. So first, electrical engineering for like web dev-y background-y stuff. We're going to talk about a couple things. The first thing we're going to talk about is signals. So when you are writing software, we use data structures and like recursion and all these concepts. But at the end of the day, everything that's moving through the software we're building is ones and zeros, right? It's ones and zeros, binary. And in electronics, you kind of have the same situation. You have ones and zeros, logic low and logic high. And they're represented by a couple different states. So the specific voltages depend on the board you're using, because boards all have a favorite voltage, which is usually their power supply voltage. But generally, a zero is going to be represented by 0 volts relative to ground or ground. And your 1 is going to be represented by high, which is usually the VCC voltage or the power supply voltage, which is great, because now we have ones and zeros. And like we discussed, everything is made of ones and zeros, so we should be done, right? Wrong. There's a bunch of other stuff we have to communicate too, because electronics actually interacts with the real physical world, and the world is not binary as much as we'd like it to be. So we have to deal with all sorts of stuff that's kind of in that hazy zone in between. And these would be called like analog signals. So analog signals are how we model everything between that 0 and that 1. And these are generally kind of like a ratio. So like if you have an analog signal, you're going to break it down to like a ratio of the voltage between. So like usually some value of over 1024 or something, depending on sensitivity. And that's cool. We'll use these a lot to like read information from the outside world where there's hazy things, like temperature is not always 1 or 0. So now we have ones and zeros and everything in between. But we're not done yet. There's one more kind of signal that we're going to be dealing with in kind of building our first IoT thing, and that is PWM, which is short for pulse width modulation, which is a really, really big topic, and there are whole books written about. But it's essentially another kind of analog signal that instead of having a ratio of a voltage, it's a voltage over time. So like a PWM signal that is high, like maximum value is going to be just like a regular 1, like on the previous slide. A minimum is going to be just at the bottom. And everything in between is represented by like going up and down 50% of the time, or 70% of the time, or 20% of the time. And the reason that these exist, there's like complicated reasons, but the TLDR is that motors don't like running at half voltage. So when you do that, they kind of catch on fire, and then they don't work anymore. So what you can do is you go back and forth between max and min, and then they stay happy, and they run at like half speed, which is cool, because sometimes you want to go half speed. Not always do you want to go full blast. And we'll generally be using these to kind of send analog signals out to peripherals. OK, so now we're going to do some show and tell, because everyone loves show and tell, right? I love that I can do show and tell during a talk. It was my favorite part of class in like kindergarten. It's going to be a little bluer than usual because of the awesome lighting setup. But what I'm going to do now is show you a few different components that you might run into while hacking around on electronics. We're going to start with the most complicated things first because that's the way we should do it, right? This is a Raspberry Pi, which a bunch of you mentioned you had by raising your hands. And a Raspberry Pi it looks like a little board, but it's really just a whole computer and a tiny, tiny little board. And this means it comes with a lot of things that we're used to from our web dev backgrounds, like an operating system, file systems, virtual memory, network stacks, all those things that we've come to depend on, which is cool. It can also run Node.js, which is awesome. We'll be using that to run Node.js. It has pins here, and you can use these to interact with the outside world. But generally, I caution people against that for their first few projects because the Raspberry Pi is powerful, but it is also sensitive. And if you give it bad mojo into those pins, it will burn up, and then it won't work anymore, and that's sad. So we're going to switch to a different, very similar looking, but very different board inside. This is an Arduino. There's lots of different flavors of Arduinos out there. This is an Arduino Uno. It's one of the more popular ones. And it is kind of the opposite of the Raspberry Pi, even though they look very similar. So this is, when we write code for this, we run code right on the metal. There's not really an operating system on there, which means we don't have things like network stacks or file systems or Node.js. But in exchange, what we get is a whole bunch of pins that can interact with the outside world, so we have more pins. The other thing we get is we get super precise timing. We know exactly when our code is going to run because there's no other code running, no context switches, which is great for embedded systems sometimes. And one of the reasons I use the Uno for a lot of my projects is it's really durable. You can do terrible, terrible things to it, like do negative voltages on pins, and it'll turn off, but it usually won't break, which is great. I think I've only broken one of these, and it was silly. But I've broken a lot of Pis. So let's see. Let's look at some other components real quick. So this is a wire. It's a piece of metal with some insulator around it. And what wires are, it seems like a silly thing to talk about. But in electronics, kind of like paralleling it to software, wires are how we copy state from one place to another. And when I think about this way, it gets a little bit easier. Sometimes, though, we don't want to attach everything with wires to copy state. So there are these handy-dandy things out there called breadboards. How many of you are familiar with breadboards? Most of you. So I will be quick here. But I found this really cool transparent breadboard. But the way a breadboard works is it's a bunch of little clamps here. And you can push components into it, like wires and other components. And it holds them. And when it holds them, what it's doing is it's holding them with a little metal clip. And the metal clips work just like wires. Sometimes you don't always want to solder stuff together. And so there's a whole bunch of clips that are in these rows, and whenever you plug components into those rows, they'll all be kind of, state will be copied along that rail. So there's a whole bunch of these horizontal ones with kind of a gap in the middle, and that's so you can fit a microchip in the middle, a certain kind of microchip. And then there's also these two long rails on the side, which by convention are used for like reference 0 and reference 1, voltage and ground. But you don't have to use them for that if you want to be crazy. OK, so, oh yeah, and these are great for like putting things together when you're on your desk. But one thing I really encourage people to do is once you build something cool, take it into the outside world and like have people use it and learn if it's actually useful, and like you'll get a bunch of feedback and things will get much better. Breadboards are not usually great for that because if you shake them, all the wires fall out and then your thing stops working and you're sad. So when you're ready to get some testing in the real world, there's this thing called perf board, which stands for perforated board. And it comes in all different flavors. But you can just find ones that are just like these simple boards that you just solder stuff onto and build your little circuit out. But some of my favorite ones to use are these that look just like the breadboard. And the reason for that is I can just copy all over my design, and then I don't really have to think a whole lot about what I'm doing. I don't have to like translate my circuit to a different orientation, which is a place I sometimes get mistakes. And sometimes mistakes cause things to break. And then I'm sad because I have to order something else. Cool. OK, so we have perf board and proto board. Just a couple more components. Oh yeah, a button. This is a push button. The way push buttons work is they have some pins on them. This is a fancy one. I put pins on it so it plugs into the breadboard better. And there's two different sides. And when the button is up, like it's doing right now, it's not copying any state. When you push it down, it connects those two pins, and then it starts copying the state. This seems like there's some nuance in this, which we'll get into later. But it only copies when it's down. Just one more component, or actually two more, because we need the minimum number of components to build something fun. This is a light-emitting diode, which, if I can get it to behave, will sit so you can see things. So light-emitting diodes are like little light bulbs, except they're directional. If you notice, the pins are slightly different lengths. And the way it works is when you have a logic 1 on the long pin and a logic 0 on the other pin, the short pin, it will light up. If you have a 0 on both sides or 1 on both sides, it will not. It will also not light up if it's backwards and there's a 1 on this side and a 0 on that side. So it's a little, like a little logic expressor, the simplest output. And then one more thing, this is a comically large resistor. It is, one way to think of resistors is they are terrible, terrible wires. So they do a lot of things that wires will do, but very, very badly. So if they're next to a wire, both hanging out on the same thing, the wire will take over and do the work, and the resistor will just be terrible. You wouldn't think you would need a terrible wire, but they come in handy a lot. And they come in a lot of different values with a lot of different stripes on them. You can read the stripe code to know how bad of a wire they are. But rather than memorize the stripe code, I just organize them like this. I put them in a little bag, and I write the value up there. These are 10K ohm. So there's lots of kind of resistors, but for the sake of this talk, only one kind of resistor exists. It's a 10 kilo ohm resistor, which is this kind. OK, show and tell, done. Now we can move back to slides, because who doesn't like more slides? Oh yeah, components. So I just showed you a bunch of components. We did a show and tell. And I always kind of think of these components as like Legos, because I used to love Legos. Actually, I still love Legos. And except they're like Legos that when we put electricity into them, sometimes they move around and do stuff. And if you put electricity into them wrong, they catch on fire. But that's OK, too. It's kind of cool. OK. So now, I've shown you some things. Let me tell you about my favorite recipe. This is a recipe for building one of something, which is important because this is not the kind of recipe you would want to put in production and build 10,000 of something. It is focused on rapid development rather than cost per unit, which is different. So we're going to be making one of something. So my recipe for one of something is components, like the ones I just showed you. Plug them in together, put them in a breadboard, put them on perf board. And that's how we interact with the outside world. So that's how we sense the outside world and then express information back to it. And we'll take those components and we'll plug them into an Arduino Uno, because the Arduino Uno is very good at working with the outside world. We're not going to write C code on the Arduino. Instead, we're going to install a program called Fermata, which is both a program that comes with the Arduino SDK and a protocol for communicating between a microcontroller, like an Arduino, and a higher level computer, like a Raspberry Pi. Although during development, any real computer that can run Node will work here. I use a Raspberry Pi when I'm actually taking it out into the world. But the cool thing about Node is it runs basically the same on the Pi as my laptop. So I can actually use my laptop when I'm doing development, which is kind of nice. Because SSHing into the Pi is kind of hard sometimes. Then on the Pi, we're going to run Node.js and a library called Johnny5, which is a Node-bot library. There are a bunch of Node-bot libraries. Johnny5 is my favorite. And then finally, we've gotten to the point where we have thing, but we don't have that Internet of Things. And this is where I will add some pepper and some Firebase to give our thing internet. So I'm going to dive a little bit deeper into a couple of those things. The first one is Johnny5. Johnny5 is awesome. I love Johnny5. And the reason I love Johnny5, we will see once the GitHub page loads. Hope for the Wi-Fi gods to help us out here. But yes, Johnny5 is really cool. It has lots of great features and stuff, but my favorite part about it is actually the documentation, which is not something you might think as being your favorite thing. And the reason documentation is so great is because whenever it's kind of like, at least the GitHub page lists a whole bunch of components, and each component has its own little documentation page, which I will show you shortly. And that component page has a sketch, like a hello world sketch. By sketch, I mean an actual schematic and drawing. So if we look for button, There's a whole bunch of components listed here. Let me make this a lot bigger. So if we go find button and we click on button, the button page will show us first a picture of exactly what you want your breadboard and Arduino to look like for this thing to work, which is great because you don't have to think about it and you don't have to know any electrical engineering. Just copy the stuff and change identifiers if you need to, which we can all do. We've learned that from Stack Overflow. It's kind of like that, but with pictures. And then along with each one of these pictures of like a circuit, there is a program, a Node.js program that works with that picture. So if you paste this code in and then do node program, that thing will happen and it will start working. And what's cool is these are basically composable. So sometimes you have to change identifiers, but you can go to pretty much any component on here, whether it be an IR proximity detector, or I think LiDAR is in here. If you go buy your laser radar device, you can also put that in, copy the things off the web page, and like combine them together, just like combining together a bunch of Lego designs, which is pretty cool. That's why I love Johnny 5. So the next thing we're going to talk a little more about is Firebase. So the way I think of Firebase is kind of like a big bag of goodies that makes app development easier. And there's a whole bunch of different goodies that are part of the bag. There's a whole bunch. There's like 3 that I just picked out because some of them are more mature ones. But there's a bunch more now that came out in the last few months. Things like a real-time database, authentication, because nobody likes implementing OAuth themselves, our static file hosting for your pure JavaScript, HTML web apps. And these things all work independently, so you can use just hosting if you want, or just the real-time database. But they work really well together, too. But for this thing, we're only going to be using one of the Firebase goodies, which is the real-time database. And the real-time database is a web database that's kind of centered around building real-time applications. And I will share a couple of these to explain the concept. So real-time applications are applications where like the data is most useful shortly after it is created. Like this. This is a bus map, because when you are waiting for a bus and you're cold, you don't care where the bus was an hour ago or a month ago. You care where the bus is right now. And this is actually where the buses in my hometown of San Francisco are right now. And you can see them moving around. So that I know that there's like 4 9s clustered down here, which is why my 9 bus is not here yet. They're all down there having a party or something. And this, you can write, this was written in like 100 lines of code, which is one of the things that makes Firebase cool. And you can go to it if you want. There's a bunch of transit systems on there. Another thing is collaborative drawing. Like, when you do a Google Docs and you have like a chat while on those comment threads and this is kind of like that. So anytime real-time collaboration happens, being able to get those things back and forth in real time makes it a lot easier to use. And normally I would actually, not just because this is Dinosaur.js, but I would encourage people to go to firesketch.firebase app and help me draw a dinosaur. But we're not going to do that now. But you can do it. Like if you have a laptop handy, go to firesketch.firebaseapp.com and draw a dinosaur, and we'll look at it later. You can tell me how fun it was. I'll start though. So I'll draw the rough. I'm not a very good sketch person. My dinosaur's a little bit sad. But yeah, if anyone else goes in, you can actually see each other kind of sketch back and forth, which is pretty cool. And yes, if anyone's sketching on there, I'm trusting you because you are drawing on my presentation. No one's ever been bad. OK, one time somebody was mean, but I had the person next to them rat them out. OK, so I just showed you a couple demos. There's things. How does Firebase actually work? Where's the code? Let me show you some code. This is the basics of Firebase. The first thing you will want to do with a Firebase app is actually connect to it. Firebases are represented by URLs, because URLs are a cool way of representing things. And on that URL, you can kind of think of your data as a giant ball of JSON, because we love JSON. And you take whatever data you're working with, like, and you kind of express it as some subset of that JSON, like a big tree. And then your clients can connect and subscribe to changes on part of that tree. And then we'll send you an update every time something changes. So connecting is pretty simple. You just like initialize your application. You give it a URL of your Firebase. You give it authentication credentials because security. And then you tell it where in your Firebase you want to connect. This example, we're looking at / the root. To write data, you for a given path, like the reference I just created, which is on the root. To write data, you can do set. Set just takes the data and pushes it to that location and stomps whatever's there. We also have other write commands like push. If you want to do like a chat room, it'll just do a push with, it'll push the data in with a monotonic identifier, universally unique monotonic identifier. That's a mouthful. And when you want to read data, instead of like reading like a REST API and actually doing a fetch, what you do is you create a listener just like you'd create a listener, like a click listener in jQuery, except instead of listening for clicks, you're listening for changes to data on the internet, which is kind of cool, because it works just as easy as that click listener. You just put a listener on. Like in this case, I'm putting a value listener on that is listening for changes to that root location, and then I'm logging it out whenever it changes. OK, so code. OK, so now we put some stuff together, and we have like I covered kind of the background. Let's take a few minutes to actually build something pretty much from scratch, which is this is one of my most highest risk demos, so we'll see how well it goes today. We're going to build the hello world of electronics, an LED, and a button with internet. So we're going to leave this for now. We're going to bring back my handy dandy show and tell projector. I'm going to move the board we're going to use, boop, which has a little breadboard next to it, and it's an Arduino, just like any other Uno, except this is a Metro, which is Adafruit's flavor of it. And what's cool about it is you can actually plug a micro USB in, so you don't have to carry around a bunch of different kinds of cables. It has some other neat things too. Adafruit's boards are all awesome. So we got our Arduino in there. We've plugged it in. And the first thing we're going to do is we're going to put a sketch on it so that we can interact with it from Node. And we're going to fire up the Arduino IDE. And we will see some C code, but don't worry, I promise you won't have to touch it. And we're going to get Fermata, unlike you don't have to look very far, because it actually comes with Arduino, and it's actually packaged with the examples, which I always found kind of strange. But I guess it's an example. But you can, yeah. Well, anyway, we're just going to install standard Fermata. We'll bring it up. It's a neat sketch. And it's actually really smart and cool, and it's pretty small. So if you ever need to extend it or something, it's actually pretty easy to extend, which I was pretty impressed by. But anyway, we're going to upload that up to our board. We're going to compile the sketch, and it's going to complain because there's something wrong with the port selection because Arduino. So I will tell it that it is plugged into USB, and we'll try again. And this time, it will actually start uploading, which is good, because we like it when things upload. And it is done. And that's cool, because now we can close our Arduino IDE, and we don't have to open it again for the rest of the talk, which is cool. So now let's move on to actually building our thing. So live coding is fun, but live copying and pasting is lower risk. So we're going to do that. It also kind of captures how I usually use these things. So the first thing we're going to do is we're going to get the LED working. So I'm going to go find LED on here. There's a lot of LEDs, so I won't use browser search because it will go through all of them. We want the simplest LED article, LED. This one has a picture of an Arduino that is coming down now, which is into pin 13 and ground. So what's here is the short pin is plugged into ground, which is at reference 0, and then 13 is where we want the long pin plugged into. Cool, we can do that. So I'm going to do that right now. Oh yeah, just some comments on the Arduino, like a little bit more of a kind of tour of it. All of your digital inputs and outputs are on this side. It can do both. Some of them have dots or squiggles or other marking on them, and that means that they're capable of being a PWM output. So if we ever need to output PWM. Analog inputs are all on this side. They are input only, and they're marked with a little letter A, which you can kind of see. And then there's a whole bunch of other pins over here that are kind of like reference 0 and reference 1 are there. So the first thing we're going to do is copy over. Before I do that, I'm going to unplug my Arduino, because if you work on your Arduino while it's plugged in, it might get sad because of shorts and things. Short circuits are bad. So the first thing I'm going to do is kind of set up my breadboard. So I'm copying over reference high, that 5 volt, and that reference 0. So let me grab a gray wire, which hopefully you'll be able to see is different. We're going to ground. So we've copied over to the little plus side. We've copied over a reference. Wow, I've never seen my hand that big before. We copied over reference 5 volt and a reference 0. We're going to plug our little LED in with the long pin on top. And then if we look back at our picture, it said that the little pin has to go to ground. So we're going to connect the little pin to ground, which is this one. Boop. And then we're going to connect the longer pin back to 13, which is conveniently located right next to our LED. Great. OK, so now we can plug this back in. We can see the Arduino's flickering a little bit. Pin 13 flickers a lot. It uses pin 13 for some internal stuff too. Anyway, we're going to copy this program. We're going to go over, clear my terminal, because I was futzing around getting my little camera to work. Good. We're going to go to dinosaurs are awesome, because they are. I'm going to make this. That's pretty big. Oh, wait, do I actually? OK, so anyway, we're going to vim. Yeah, we'll do that Dino.js. We're going to paste code in. We're going to use Vim, the only editor that the world needs. And then we're going to get rid of some stuff we don't need. That REPL stuff, it's cool. It's for interactive, doing it on the little terminal. We're not going to do that today. And then I thought I npm installed stuff already. Hopefully I don't have to. Let's find out if it works. Cool. OK. So I already npm installed Johnny 5. I would do that on stage, but I don't want to make you all wait and be sad. So now, if our program is running, we can see it running. It does not have much output on the terminal, but if we had any output, we'd see it down there. And we can see that our program is actually working. Oh my gosh. We copied and pasted code, and our LED is blinking, which is neat. We like blinking things. OK, so we have something working, but the LED was only half of our thing. There's another part of the thing, which is the button. So the button to work, we're going to go back to that button page, and we're going to copy this page. So I'm going to put this down in the corner, and I'm going to copy it up here. And first thing first, make sure the program is stopped. It is stopped, and then we're going to unplug the Arduino so things don't catch on fire on stage, because that's awkward. Then we're going to grab a button. We're going to use my comically large button I had out here earlier. Oh, here it is. I thought I lost my comically large button. We're going to put it in there. And then what we hook up here, it seems pretty simple. We hook the button up to reference high on one side, and then we hook the other side to digital 2. It's not 13. It's great. We don't have to do any number fudging. So now we're going to take the bottom pin, and we're going to put it onto 2. And then we're going to do that kind of reference high, which I'll do with this white wire. And we're going to put that on the other side. Boop. OK, and you might think that you're done now, because the button is plugged in, and it goes to an input. So it should just work, right? Not really the case, because we're dealing with the real world, and the real world has physics and stuff. Because what happens now is when the button is hanging out, when we push the button down, we're copying over that reference high. We're sending electrons over to the other side, and we're reading them from the pin. But when we pick up off the button, those electrons are just hanging out there on our read pin. And the Arduino's pretty good about not dissipating too much energy when it reads. So it's just going to sit there and kind of flicker back and forth between up and down, and then finally go to down seconds later, which is way too unresponsive. So what we're going to do is we're going to add something called a pull-down resistor. So we're going to take our comically large 10K ohm resistor, and we're going to shunt this to ground. So what this does is when the button is pressed down, we have the 5 volts coming in, and they go to our input pin. And they do this because there's a good wire there. When we lift up, that good wire is not doing anything anymore. So because there's no input signal coming in to read, so we kind of trickle out the extra electrons through this terrible wire, the resistor. So that is our button circuit. So we're going to copy some stuff, just like copying and pasting, because why not? So we're going to make a new button, back to Vim. We're going to react when our button goes down and when our button goes up. So I'm going to copy and paste all this stuff out. But we don't care about this hold stuff. I'm going to get rid of that. We only care when the button goes up and down. Instead of the LED blinking, we just want it to go on and off. So boop. So now when the button is up, our LED turns off, and when the button goes down, our LED turns on. Cool. OK, so we've combined both of these things, and we've made a more complicated thing. Let's see if it works. The fun part. So I'm going to bring back terminal. We're going to plug our Arduino back in. No smoke. It's still, oh, it's just hanging out right now. We're going to run our program again. And now when we push the button down, the button turns on. When we lift it up, it goes up. Cool. So we have our thing. We have a thing, which is cool. But our thing is lonely because it cannot go on the internet. It does not know about the internet. And we want our thing to be less lonely. So we are going to add some internet. And per my previous pattern of just copying and pasting, we're going to continue with that. So we're going to go to firebase.google.com/docs. And we're going to go to the Firebase documentation and go to a quick start, and we're going to copy some stuff off. Because docs are cool. So we're going to go over to web, because web is JavaScript, and JavaScript is close enough to our IoT thing, because they're both running JavaScript. We're going to go over to the Getting Started guide, which gets us most of the way to the right place. But we're going to shift a little bit. There's a server section that's kind of hidden up here. And we're going to use the server code, because our robot is more like a server, or rather, it's not really a robot. Our IoT device is more like a server than anything, and then we're just going to follow the instructions here. So the first thing we would do is we'd install Firebase, and then we're going to connect to Firebase. So we're going to connect. Where is my, there we go. So we're going to install Firebase essentially. Then we're going to connect. So here's connecting. I'm going to copy a file over, because I could go through a bunch of web pages and show you how to get the auth token. But to save time, I'm going to copy some, what do I have? GlueAuth.json. I'm going to copy the auth credentials I prepared ahead of time to reduce the number of websites we have to hit. So this is, it's just it's a Google Cloud Platform identity token for a kind of like a headless account, which is how we're going to interact with our Firebase securely. Well, it was secure until I showed you all of the letters in it. So we're going to use that to communicate, which is just servers account path to credentials. Oh, cool. GlueAuth.json, and we're going to connect to a Firebase. Why not one called ESP button? So that's our database URL, and then we're going to do something with it. So like, how about let's go back to web and find out how to change things. It used to be at the bottom of that doc, but it has moved. So anyway, what we would do is we're going to kind of work into Firebase. I'm not going to stop copying and pasting. I'm actually going to live code. Styled. So we have a ref. Oh, actually, I have to connect and stuff. Let me go over to my, oh my gosh, my talk was, yep. My backup, pre-working one. We're going to copy off the connection stuff, because it changed a few weeks back, and I forgot it. I know, fail. What we're going to do is we're going to connect to the Firebase real-time database, because you can use this to connect to all sorts of different Firebase services. Then we're going to move into it a little bit to a path called button, just in case we want to use this Firebase for more than one thing at some point. And then we're going to want to do a read from Firebase. The way we do this is, remember that the listeners, we're going to use a listener here. So when the value changes at our reference, we're going to do stuff. We get a snapshot back, which is contains a bunch of other metadata, and it's also kind of a snapshot of the It's a a read-only snapshot of the data at the time the event occurred, just in case things change in the meantime while you're processing it. And so we're going to first extract our value from that. So a snapshot.val. And then, oh no, I'm off by one space. I can't let that stand. If val equals down, do stuff, else do other stuff. And what we're going to do here is we're going to turn the LED on and off. So when the button is down, the LED will turn on. When the button is not down, we'll turn the LED off. So we have half of it now. So when we run this program, we'll actually be reading state from a Firebase to control our LED, but we're not doing the write yet. So the write side is much easier. When the button goes down, we're gonna take our ref.set down, and then when the button goes up, we will write up. And now our thing can talk to Firebase. And now all our state is moving through Firebase. So let's see if it actually works, which is the true test. Node Dino. So, it's unplugged still. So we're going to plug it back in. We are going to bring up a little dashboard, which has data in it, like I've practiced or something. This is just a database viewer for Firebase. Nothing too exciting, but it is fun to play with it. It does update in real time, like everything else. We're going to run. Now that we're plugged in, we're going to run, and it's going to write a bunch of stuff. OK, so our button's hanging out. Nothing's really going on. When we push it down, it changes the web page, and then comes back and changes the LED. And we lift up, it toggles back and forth, which is kind of cool because now we've built the most overcomplicated LED thing ever. And because it's communicating with the internet, it doesn't have to be lonely, because if someone had made another identical one before, they can actually interact with each other, which is kind of cool. So one way of thinking it is that we've made the most overcomplicated telegraph ever, which is cool. But anyway, back to slides, because we're almost done. Boop. So yeah, silly demos. So what's cool about this is it can interact. Once you created this thing, it interacted with my web browser and that console, but it can interact with anything else that can connect to the internet. And it's pretty much the same code can be used in anything else that runs JavaScript, like my slide deck. So I can make it so when I hit the button, it tries really hard to load a YouTube video to rickroll my slide. Not as dramatic as sometimes happens, which is pretty cool. Anyway, we'll skip the rickroll today. I will save you from it. Oh my gosh, people wrote Trogdor and rar. You're all awesome. But using pretty much the same technique and a couple potentiometers, just little dials, I just copied stuff off the Johnny 5 page, and I'm going to ruin this drawing now, because I made a terrible Etch-a-Sketch, which is not sketching today. Oh, there it is. It's way up at the top. So you can kind of see that I'm scribbling over it using this terrible, terrible Etch-a-Sketch. But this is another example of something you can build with the exact same technique and a Raspberry Pi and a battery in a box. Oop. OK, so parting words, which I'll go through quickly. Wasn't that easy? I hope so. Another piece of advice is we always have an urge to go out there and invest in that Kickstarter and get some new shiny board, which is fun to do. But generally, when you want to do kind of hardware hacking, I encourage people to let projects guide their hacking, and that keeps our stashes at a sane level, which is cool. And definitely experiment. One thing I love to do is find electronics from the 1970s and tear them apart, because you can actually see how people did stuff back then. Which is cool. So experiment, reverse engineer, try things. Don't be afraid about the last one, which is inevitably when you do this stuff, something will eventually catch on fire. Blue smoke will come out and things will stop working. That's OK. Celebrate that it happens. You can probably get that thing delivered to your door in a couple of days anyway. So have fun. And yep, so now I challenge you all to go build cool stuff. Here's the code and slides and stuff. And I look forward to seeing what all of you come up with.
What was your first hardware project that got you into this?
Wow, what was my first hardware project? Probably something involving Legos and reverse engineered like Technic robot Lego stuff, which I probably broke right away. I don't know, it's all blur. But it was almost certainly something I took apart as a child and tried to turn into something else with limited success.
I guess it's a lot of people's introduction to hardware without even realizing it, because I'm saying like, oh, I've never really done hardware, but I used to like break everything as a kid just to see like how it works, and of course not know how to put it back together. But,
yeah,
like,
just embrace that as an adult.
Yeah.
You can still break stuff.
Yeah. Do you recommend any places to buy hardware, or like what kits or anything like that to get started? Because it's all very like, it could be pretty overwhelming. There's a lot of stuff out there.
Yeah, so my general guidance, like I always tend to end up, like I always look for new places to get stuff and new places to get inspiration. But I always kind of end up back on Adafruit's site, Adafruit. She's out of New York and she's awesome. And like they have, whenever I need a component, she seems to already have it, even if it's like relatively weird stuff. Like I need pogo pins to make a chip program. Oh my gosh, Adafruit has them. They also have this Learn section, which has all these amazing projects, which are really fun just to straight up implement, and then fun to hack from or mash up in interesting ways. But wonderful documentation, and just like they seem to have all sorts of great stuff.
That's cool. The documentation is really important because, like, up until recently, documentation for electronics and hardware, again, for me, has not been really visual. Fritzing diagrams are like super cool to like watch. And I want to shout out to my coworker Rick Waldron for Johnny 5 and for showing me fritzing diagrams because he's got me super into that. Thank you so much.
Thank you.
Welcome to Gen Conf, by the way.